this problem we are giving a matrix. So inside the matrix it's going to be numbers from 1 to 9, as we can see from here. So the matrix ij gonna be from 1 to 9, and the row and column are gonna be more than equal to 1, less than equal to 6. Yeah, and let's just continue to check it. So we are giving this called matrix array, and we're gonna start from any number. So for example, from 1, it can go to 8 directions, and we just need to check how many different numbers it can combine. So for example, 1 1 it is 11, or 1 9 definitely it can go to 3 directions or 8 directions if that is possible. So if it can go to all those 8 directions, it's gonna combine two different numbers. So one path is 18, or another path is 191. So if it is a prime number, so we're gonna check the frequency of this number, and we're gonna return the most frequent prime number greater than 10 out of all the numbers created by traversing the matrix, or -1 if that is not possible. So if there are multiple cases, we're gonna return the largest among them. So for example, if the frequency, for example 3, we have 3 of 19, and we have 3 of maybe I don't know, maybe 91 is also a prime number. Maybe, yeah, we're gonna return 91 instead of 19. Yeah, now let's just try to solve it. First of all, we need to know how can we check a prime number. So we're gonna define a function. I'm gonna call it e prime. So I'm gonna use a Aristoteles algorithm to check. So I'm gonna prepare a primes array, and from the beginning I'm gonna set to false times 2 plus the boolean of true times n minus 1, and then I'm gonna use a for loop from 2 to n plus 1, and then I'm gonna check if primes I'm gonna use another for loop. So for j in range I times I to n plus 1 to I as the step, so the primes j gonna equal to false. And finally we're gonna return on this primes array. So the primes we're gonna call e prime, and the maximum number gonna be, so the maximum number gonna be, because at most we're gonna choose 6 numbers, so the maximum number we're gonna use 10 to the power of 6. Yeah. At the same time, let's just prepare a directions array, as there are 8 directions. So we're gonna use first of all, let's just prepare 4 directions, and then we're gonna prepare another 4 directions. So for directions 0 1 0 -1 1 0 and -1 0. And what about other 4 directions? Let's just use maybe 1 1 1 -1 and -1 1 and -1 and -1. So you should understand those directions are just the 8 directions we're gonna prepare. So for example 1, those are 4 directions, and then we're gonna prepare another 4 directions, so those 2 and those 2. So in total there are gonna be 8 directions. I think this is just the preparation, and now we can start programming. Yeah, it's gonna be straightforward. So RC gonna be length of the mat and the length of the mat 0, and let's start to prepare a counter because we're gonna use it later. So for R in range capital R, and for C in range capital C. So for example, from here, this is just our starting point. Maybe we're gonna have 11, or maybe we're gonna have a 19. Yeah, maybe we're gonna have another 19. We just need to check all the different cases. So for dr dc inside the directions array, we're gonna update the row and column. So row gonna be equal to row plus dr, and column gonna equal to column plus dc. But from here, we need to check how many loops we're gonna check. So we're gonna use 5. Yeah, because at most there are gonna be 6 numbers. So from here, we're gonna have one number, and then we're gonna use other 5 numbers. We're gonna check how many different numbers. Yeah, while we are preparing the different directions, let's just prepare the num. So we're gonna prepare the current number. So for each of the directions, right, we're gonna prepare the row and column. So the number gonna be mat r and c, and the row and column gonna be r and c. Yeah, we're gonna reassign this r and c because we're gonna update it. For example, maybe for here we're gonna check all those numbers. Maybe there are 6 numbers, or maybe this areas we're gonna check all those numbers. Yeah, it's gonna combine to a larger number. So this is the row and column, and we want to update the number. So the number gonna be num times 10. So this gonna be more than 10 because we need to put all those numbers more than 10 inside the counter. Yeah, because it's gonna be greater than 10. So we're gonna check it from here, and then we're gonna plus the mat with this row and column. Yeah, I think this should be okay. And then we're gonna check if it is a prime number. So if it is a prime number, we want to put it inside the counter. Yeah. Now let me just give a random return and print out this counter. We want to check if that is okay. Yeah, let's just check something wrong. Yeah, because for here we need to check it must be inside of the range. So if a row inside of the range and a column inside of the range. If it is inside of the range, so we're gonna check this number. If it is a prime number, we're gonna put it inside of the counter. Now let's just check what happens. As we can see, this is our counter. 19 is okay, 11 is 4, and 191 there are only 4. So we're gonna choose the maximum frequency, which is 8, and we're gonna return this number, which is 19. So this is exactly what we're gonna return, right? So first of all, let's just check if there is a counter. If not counter, this means we cannot find. We're gonna return a -1. Otherwise, we're gonna find the maximum frequency. It's gonna be d dot values. After finding the maximum frequency, we're gonna prepare a result array. So we're gonna sort the result array. Inside it, it's gonna be array. So we're gonna prepare k. So for k, they in d dot items, if they equal to max and reverse gonna equal to true. And finally, we're gonna return the first number because it has already been sorted. Yeah, now as you can see, it works. Now let me just submit it to check if it can pass. As you can see, it passed for all testing cases, and it's pretty fast. So what is the difficult part of this problem? First of all, we need to understand how to use the method from the Aristotle's algorithm. We need to find which number gonna be a prime number. Definitely, we're gonna ignore the time complexity from here, even though this is 10 to the power of 6, but this runs just one time. And then we're gonna analyze the time complexity from here. So this is a for loop. So this is a 6, another 6. Direction is 8. Yeah, it's just small numbers. It is 6 times 6 times 8. And here is 5 times 5. Yeah. Do we have anything else? No. So this is the time complexity. It seems it is smaller than 10 to the power of 4. Here we used sorting, and for the sorting, maybe n log n 10 to the power 4 times log 10 to the power 4. Actually, it will be much smaller than that. I think that's all about it. The time complexity gonna be yeah, it's gonna be dependent on how many values inside the dictionary. So maybe the maximum value is going to be 10 to the power of 4. I don't know. Yeah. And we also need to check if that is a prime number. I think I forget about something, but here this is just 01 time. I think this is okay. This is just 01 time. Otherwise, maybe we cannot pass. Yeah. So the time complexity, maybe it is 10 to the power of 4 times a log 10 to the power of 4. It's gonna be a very small number. I think that's all about it. Thanks for watching. See you next time.